Hi everyone, welcome back. So I'll just quickly draw the RAS signaling domain again. So the example that we used is RAS GAP, GAP, and it consists of an SH2 domain followed by an SH3 domain followed by an SH2 domain followed by a PH domain, then a C2 domain, and then a RAS GAP domain. Okay, so that is the structure, the domain structure of RAS signaling proteins in general. Let's move on to the next one. The next one would be of a transcriptional protein, and the example we'll use is the STAT protein. And the STAT protein has a DNA binding domain, and obviously this is important because transcription proteins have everything to do with DNA. So they have a DNA binding domain followed by SH2 domain followed by a TA domain. Okay, so that would be your STAT protein. Then the last one that we have is, let me just get rid of that. Oops. Just wanted to get rid of this thing here. There we go. So this one is phospholipid second messenger signaling. Phospholipid second messenger signaling. And the example of this is PLC, phospholipase C gamma. Okay, now this has a very interesting structure. PH domain, then it has a PLCXC domain, then it has a split PH domain, so it's not a full PH domain, just a split one. Then it has an SH2, SH2, SH3, and then there's this other part of the PH domain, the other split part of the PH domain, followed by PLCY, C, and then a C2 domain. So I know this might seem very intimidating right now, but as you move on and get to learn more about these domains, it'll make a lot more sense. So don't get frightened. But you do have to memorize it. So it's like memorizing a bunch of alphabets pretty much, but yeah, that's what it is. And the interesting point is, the important point I think here is the split PH domain. Alright, so those are all the different examples I had, and in the next video we'll talk a little bit about the 14-3-3 proteins, and it's sort of like an aside from the main course, like it's a branching off topic, but we'll go over that, and then we're back to our signaling concepts, and we'll talk about these different channels and different receptors that we have, followed by some background information on GPCRs because they are the most important ones and the largest family of receptor proteins. Then we'll talk about the general structure and function and how their response is transduced and how it's terminated. We'll talk about some diseases that can happen because of defects in the GPCRs. And then we go on to second messengers. We'll talk about cyclic AMP, its discovery, and just a little briefing on it, and then we'll also talk about phosphatidylinositol derived second messengers, so PI derived second messengers, and then we'll talk about PI3K kinases, so phospholipid kinases. A few more topics here and there. And then we'll start with protein kinases. So still a lot more to go, but I'm sure we'll get there. Alright, see you in the next video.